Hey everyone, welcome to our deep dive. Today we're turning up the heat and taking a close look at the star of our solar system, the sun.
The sun.
We're going to be using some really cool research to guide us.
Oh, yeah?
A scientific paper full of astrophysics,
Right.
and also the always reliable Wikipedia page on the sun.
Yeah, always a good source.
To uncover some seriously mind-blowing facts about our nearest star.
Sounds good.
I mean, you might think you know the sun, right? We see it every single day.
Yeah.
But trust me, after this deep dive,
Mm-hmm.
you're going to discover a whole new side to it.
Yeah, it's easy to take the sun for granted.
Totally.
It's just kind of always there.
Yeah.
But the science behind this celestial powerhouse is truly mind-blowing.
Yeah. And speaking of mind-blowing,
Right.
remember that incredible image of Sagittarius A?
Oh, yeah.
The black hole at the center of our galaxy?
Back in 2022, that was everywhere.
I know. It was like we were staring right into the abyss.
It felt like it. It really did.
But that image was more than just a cool picture, right?
Oh, yeah, absolutely. It provided the first really solid evidence of black holes.
Right.
Which had been theorized for a really, really long time.
Like forever.
But we had never directly observed one.
Yeah. So no black hole in our backyard, but we
Right.
do have the sun.
We do, this gigantic
This giant
ball of plasma
Yeah.
just dwarfing our planet.
So let's just get some of the basics out of the way first.
Right.
We know the sun is huge.
It's massive.
109 times wider than the Earth.
Wow.
It's ancient, like 4.6 billion years old.
Yeah.
And it's mostly hydrogen and helium,
Hmm.
which makes sense considering it's a G-type main sequence star,
Right. A yellow dwarf.
or as astronomers like to call it, a yellow dwarf.
Yeah.
But I'm guessing there's a lot more to it than just size, age, and what it's made of.
There is definitely more to it.
Right.
Absolutely. The sun's structure
Yeah.
is surprisingly complex.
Oh.
It have all these distinct layers,
Oh.
kind of like an onion.
An onion, okay.
You start with the core,
Mm-hmm.
then you move out to the radiative zone.
Okay.
Then there's something called the tachocline,
The tachocline, okay.
followed by the convective zone, the photosphere, chromosphere, transition region, corona,
Wow.
and finally the heliosphere.
That's a lot of layers.
That's a lot of layers.
I'm already getting lost.
Okay, well.
What's this tachocline thing? I've never even heard of that.
Okay, so the tachocline is like this boundary zone
Okay.
between the radiative zone and the convective zone.
Mm-hmm.
And it's actually super important in generating the sun's magnetic field.
Oh, wow.
Think of it as this
Okay.
swirling dynamic region
Yeah.
where different layers of the sun are rotating at different speeds.
Okay, that makes sense.
Yeah.
So we've got all these layers,
Mhm.
but where does all of that solar energy come from?
Right.
It's got to be more than just a giant campfire, right?
Yeah, it's definitely not a campfire.
No.
The sun's energy comes from nuclear fusion
Oh, I.
happening deep within its core. Imagine hydrogen atoms just smashing together
Okay.
at unimaginable temperatures and pressure,
Yeah.
forming helium.
Oh,
And this process releases just this incredible amount of energy.
okay.
Every second,
Mhm.
the sun converts 600 billion kilograms of hydrogen into helium
600 billion kilograms per second.
per second.
That's wild. I mean, to put that into perspective,
Yeah.
that's enough energy to power Earth's current energy consumption for millions of years.
Millions of years.
It's just mind-boggling.
Mind-boggling.
And all that energy eventually radiates out from the core
Right.
through all those layers we talked
Yeah,
about and
yeah.
finally reaches us here on Earth.
Exactly.
That's a pretty impressive journey
Yeah. Yeah.
for a burst of light.
Yeah.
So we know the energy comes from the core,
Mhm.
but what about those dark spots we sometimes see on the sun?
Right.
Those sunspots. Are they like holes in the sun or something?
Well, not quite holes.
Okay.
But they are fascinating.
Okay.
Sunspots are cooler, darker areas on the sun's surface,
Mm-hmm.
and they're closely linked to the sun's magnetic field.
Oh, okay.
Think of them like giant magnetic knots
Okay.
that rise up from the sun's interior
Uh-huh.
and poke through the surface.
Okay, so they're magnetic, but why are they cooler?
That's a great question.
Yeah.
So these magnetic knots,
Mm.
they actually suppress the flow of heat
Oh,
from the sun's interior,
okay.
which is why they appear darker and cooler.
So they're not actually holes, they're just
They're just cooler.
cooler spots.
Yeah.
Okay.
And they can actually affect us here on Earth.
They do.
Okay. How?
So sunspots
Okay.
are often the sites of solar flares and coronal mass ejections,
Hmm.
which are these bursts of energy and plasma
Okay.
that can blast out into space.
Oh, wow.
Yeah. And I've heard about solar flares
Yeah.
causing problems with things like satellites and even power grids here on Earth.
Yeah.
It's like the sun throwing a little temper tantrum.
Yeah, it is.
And these temper tantrums
are all part of the sun's natural activity cycle.
Okay.
So it's not just constantly churning out energy.
Right.
Its activity actually rises and falls over an 11-year period.
Hold on, the sun has cycles.
The sun has cycles.
Okay, tell me more about that.
Yeah. So picture this. At the peak of the cycle, called solar maximum, the sun is this chaotic mess of sunspots, solar flares, and coronal mass ejections.
Wow.
It's like a teenager going through a growth spurt, a little unpredictable, prone to outbursts.
Yeah.
But then as the cycle progresses towards solar minimum, things quiet down and the sun becomes much calmer.
So it chills out a bit.
It chills out.
Okay.
Fewer sunspots, less activity.
So we're basically at the mercy of the sun's mood swings.
We are.
That's kind of a scary thought.
It is a little bit.
But these cycles have been going on for a while.
Oh, yeah. The sun's been doing this for billions of years.
Yeah.
And it's all thanks to something called differential rotation.
Differential rotation.
Okay.
Another term I haven't heard before.
So it means that different parts of the sun rotate at different speeds.
Oh, wow.
The equator actually spins much faster than the poles.
Interesting.
And this difference in rotation is actually what drives the sun's magnetic field and those wild solar cycles.
So even the way the sun spins is complex.
Yes.
Okay, so we've talked about its size.
Yes.
Its layers, its energy source, these temperamental outbursts, even its spinning habits. But I have to ask, what happens when the sun runs out of fuel?
Right.
Is it just like, fade away?
Well, it's a little more dramatic than just fading away.
Okay.
So right now, the sun's in its main sequence, happily fusing hydrogen into helium.
Okay.
But in about 5 billion years, things are going to change drastically. It's going to enter the red giant phase.
Red giant, that doesn't sound good.
It's a little ominous.
What happens then?
So the sun will start to swell up, becoming much larger and cooler than it is today, and it will engulf Mercury, Venus, and even scorch the Earth.
That's not good news for us Earthlings.
No, not so much.
So it's like a cosmic balloon expanding outwards.
Exactly. And as it expands, it'll shed its outer layers, creating this beautiful planetary nebula.
Okay.
A glowing cloud of gas and dust.
I've seen pictures of those. They are stunning.
Yeah.
So after the red giant phase, the sun basically becomes a work of art.
In a way, yes.
Oh, okay.
But it's not the end of the story.
Okay.
At the center of that planetary nebula will be the sun's leftover core.
Okay.
A white dwarf.
A white dwarf. Okay, what's that like?
So imagine something the size of Earth, but incredibly dense.
Wow.
With a mass comparable to the sun.
Okay.
It's essentially a stellar ember slowly cooling down over billions of years.
Wow, the sun's journey from birth to death is like a truly epic tale. I mean, we've covered a lot of ground here. Its size, structure, energy production, sunspots, solar cycles, and even its eventual fate.
We've covered a lot.
But I'm guessing there's still more to explore, right?
Oh, well, absolutely. We've only just scratched the surface.
Okay.
For instance, did you know that the sun, along with our entire solar system, is actually orbiting the center of the Milky Way galaxy?
Wait, the sun is moving. I always pictured it as being stationary, like at the center of everything.
I know, right?
Yeah.
It seems like it should be.
Yeah.
But no, it's on the move.
Okay.
It takes about 225 to 250 million years for the sun to complete one orbit around the galactic center.
Wow.
We're talking about a galactic year here.
That's a time frame I can't even imagine.
It's almost impossible to grasp.
Yeah.
Yeah.
So as the sun travels through the galaxy, is it encountering different regions of space?
Yes, absolutely.
Okay.
It encounters varying densities of interstellar gas and dust, which can actually affect the solar wind and even influence Earth's climate.
Wow.
It's like this never-ending cosmic road trip.
I love that analogy. Like the sun is on this grand adventure and we're just hitching a ride.
Exactly. And speaking of the solar wind, that's another fascinating aspect of the sun that we need to delve into.
Okay.
It's this constant stream of charged particles flowing out from the sun. And it has this huge impact on the planets, including Earth.
So it's not just light and heat we get from the sun.
No.
It's this constant invisible force shaping our cosmic neighborhood.
Precisely. And the solar wind is far from constant.
Okay.
It fluctuates with the sun's activity cycle,
Mm-hmm.
meaning it can get pretty intense
Okay.
during those solar maximum periods.
Yeah.
Think of it like the sun's breath.
Right.
Sometimes gentle, sometimes a powerful gust.
So the sun's breath can be a bit unpredictable.
A bit unpredictable.
Got it.
But despite its occasional outbursts, the solar wind is actually crucial for life as we know it.
Oh,
Yeah, it acts as a shield,
wow.
protecting us from harmful cosmic rays.
The sun is full of surprises. I mean, we've learned about its structure, its life cycle, its moods, its journey through the Milky Way,
Yeah.
and now this powerful solar wind. But before we get completely blown away by all this information, let's take a quick break and then come back
Yes.
to wrap up our exploration of this amazing star.
Okay. Welcome back. So before we went on that tangent about the solar wind,
Yeah,
we were talking about the sun's journey through the Milky Way.
that's right. That's right.
It's incredible to think about the vast distances and timescales involved.
It's hard to wrap your head around a galactic year.
Yeah.
But I'm curious, as the sun makes its way through the galaxy, does that journey have any impact on us here on Earth?
It does, yeah.
Really?
As the sun orbits the galactic center, it bobs up and down, kind of weaving through the Milky Way's spiral arm.
Okay.
And these arms are these denser regions of gas and dust, and passing through them
Yeah.
can actually affect Earth's climate.
Wow. So our climate isn't just influenced by the sun's activity,
Right.
but also by its position in the galaxy.
Exactly.
That's amazing. Okay.
Yeah.
Let's get back to the solar wind for a moment.
Okay.
You mentioned it's a stream of charged particles.
Yes.
What exactly are those particles and how fast are they traveling?
So it's mostly a mix of protons and electrons,
Okay.
along with some heavier ions.
Okay.
And they're moving incredibly fast.
Okay.
Hundreds of kilometers per second.
Hundreds of kilometers per second. That's like traveling from New York to Los Angeles in minutes.
I know, it's crazy.
It's hard to believe something so powerful is constantly flowing out from the sun.
It is one of the most remarkable features of our star. And this solar wind doesn't just dissipate into space.
Okay.
It creates this giant bubble around the solar system called the heliosphere.
The heliosphere. Okay.
Think of it as the sun's protective shield,
Okay.
pushing back against the interstellar medium.
That's
the gas and dust
What?
that fills the space between stars.
So the heliosphere is like our cosmic bubble.
It is like our cosmic bubble.
Sounds pretty cozy in there.
Yeah.
What happens when the solar wind reaches Earth?
So that's where things get really interesting.
Okay.
So Earth has its own magnetic field, right? Which acts as a shield against the solar wind.
Okay.
Most of those charged particles just get deflected,
Okay.
but some get trapped in Earth's magnetic field lines
All right.
and spiral down towards the poles. And that's what creates those breathtaking auroras,
Wow.
the northern and southern lights.
So it's the sun's breath
It is.
interacting with Earth's magnetic field that creates those beautiful displays of light.
It's beautiful.
It's just poetic.
It is.
And the intensity of the auroras
Yes.
depends on the strength of the solar wind,
It does.
which, as we discussed, varies with the sun's activity cycle.
Right, exactly.
So during solar maximum, when the sun's throwing those temper tantrums,
Yes.
the auroras can be spectacular.
It can be absolutely incredible.
Speaking of the sun's moods,
Okay.
we talked about sunspots and those dramatic solar flares and coronal mass ejections. Can those events actually impact Earth?
Oh, they absolutely can.
Really?
So solar flares are these sudden bursts of radiation,
Okay.
and they can disrupt radio communication
Wow.
and GPS signals. And then coronal mass ejections
Hmm.
are these massive eruptions of plasma and magnetic field
Okay.
that can trigger geomagnetic storms
Okay.
when they hit Earth's magnetic field.
Geomagnetic storms, those sound intense.
They can.
What kind of effects can they have?
So they can induce electric currents in power grids,
Oh, no.
causing blackouts.
Oh.
They can damage satellites, disrupt radio communications.
So it's like a whole
Yeah.
cascade of things.
Cascade of effects.
Wow.
And they can even pose a radiation hazard to astronauts.
Oh, wow. So the sun's activity can have some pretty serious consequences for us down here.
It definitely can.
It's a reminder that even though it's millions of kilometers away,
Yeah,
it has a powerful influence on our lives.
it really does.
I'm also curious about the sun itself.
Yeah.
We talked about its layers, but is there a clearly defined boundary
That's a great question.
where the sun ends and space begins?
It might surprise you to learn
Okay.
that the sun doesn't have a sharp, solid surface.
Really?
Like Earth does.
Okay.
Its density gradually decreases as you move outwards from the core.
Okay.
So there's no distinct point where
Okay.
you can say, this is where the sun ends.
So it's more like a fading out
It's a fading out.
than a hard stop.
Yeah.
That's fascinating.
So the visible surface we see,
Mm-hmm.
the photosphere,
Yeah.
is simply the layer
Okay.
where the sun becomes opaque to visible light.
Okay.
It's kind of like looking into a dense fog.
Okay.
You can only see so far before everything becomes obscured.
Okay. That makes sense.
Yeah.
So beyond the photosphere,
Mm-hmm.
the sun just keeps fading out into space.
Well, there's still several layers beyond the photosphere.
Oh, okay.
You have the chromosphere,
Mhm.
this thin layer of gas
Okay.
that can be glimpsed during a total solar eclipse
Oh, wow.
as this reddish flash.
That's amazing.
And then there's the corona,
Okay.
the sun's outermost atmosphere,
Okay.
which extends millions of kilometers into space.
The corona. That's that superheated region we were talking about earlier, right?
That's it.
Millions of degrees hotter than the sun's surface.
Yes, one of the biggest mysteries in solar physics.
I know. How can the corona be so much hotter
Right.
than the surface below it?
Exactly. Scientists are still trying to figure that out.
It's like a cosmic puzzle.
It is a cosmic puzzle.
Okay, so we've got the photosphere,
Yes.
the chromosphere,
Yeah.
and the superheated corona.
Yes.
And beyond that, it's just the heliosphere, that giant bubble carved out by the solar wind.
That's right. The heliosphere is our cosmic neighborhood, shaped by the sun's constant outflow of charged particles.
Yeah.
A very dynamic and complex region
Okay.
with its own weather patterns
Wow.
and magnetic fields.
It's amazing to think that something as seemingly simple as the sun
I know, right?
can create such a vast and intricate environment.
Yeah.
We've talked about its impact on Earth.
Yeah.
I'm wondering, does the sun have any influence on the other planets in our solar system?
Absolutely.
Really?
The solar wind and the sun's magnetic field
Okay.
extend throughout the solar system, influencing the atmospheres and magnetospheres of all the planets.
Wow.
For example, on Mars,
Okay.
the solar wind has been stripping away its atmosphere for billions of years,
Oh, wow.
which contributes to its thin and arid climate.
So the sun is not only essential for life on Earth,
Right.
but it also plays a role in shaping the environments of other planets.
Exactly.
It's like the cosmic architect of our solar system.
It is. It's this powerful force
Yeah.
shaping and influencing everything within its reach.
Mm-hmm.
And it's constantly evolving and changing and surprising us.
This deep dive has been an incredible journey so far.
It has.
We've learned so much about the sun's structure, its activity, its impact on Earth and other planets, and
Yeah.
even its journey through the Milky Way.
That's right.
But there's one more topic I'd love to explore before we wrap things up.
Okay.
We talked about the sun's eventual fate as a white dwarf.
Yes.
But what about all that material it sheds during the red giant phase?
Right.
What happens to that?
Ah, yes. The planetary nebula.
Yeah.
One of the most beautiful and awe-inspiring sights in the cosmos.
They are.
Those glowing clouds of gas and dust.
Yeah.
They're essentially the remnants of stars like our sun,
Okay.
recycled back into the interstellar medium.
So it's like the sun is giving back to the universe,
It is.
contributing to the birth of new stars and planets.
Exactly. The material shed by dying stars
Oh.
enriches the interstellar medium with heavier elements,
Okay.
which are essential for the formation of rocky planets like Earth,
Wow.
and even for the building blocks of life itself.
It's like the sun is completing a cosmic cycle,
Yeah.
returning to the universe what it has created.
It's a beautiful and poetic ending to the life of a star,
It is.
and it reminds us that even in death, there is rebirth, transformation, and this continuing connection to the vast cosmic tapestry.
Wow, that's a profound thought.
Yeah,
I think we've covered an amazing amount of ground in this deep dive.
we really have.
From the sun's fiery core to its expansive heliosphere,
Mm-hmm.
we've explored its structure, its activity, its impact, and even its eventual fate.
Yes.
But I'm sure there are still countless mysteries and wonders
Absolutely.
waiting to be discovered about our nearest star.
Yeah, the sun is this constant source of fascination and scientific inquiry. It challenges our understanding of the universe.
Totally.
It inspires awe and wonder.
Yes.
And it reminds us of our place in the grand scheme of things.
Before we wrap up this deep dive,
Okay.
there's one final question I'd like to pose to our listeners.
Right.
It's a thought experiment
Okay.
that always kind of sparks my imagination.
Mm-hmm.
Imagine if there were two suns in our sky.
Two suns.
How would that change things here on Earth?
Interesting.
How would it affect our climate, our seasons, the evolution of life itself?
Yeah.
It's a fascinating question to ponder,
It is.
and I encourage everyone to let their imaginations run wild.
Keep exploring, keep questioning, keep looking up at the sky.
Yeah.
The universe is full of wonders waiting to be discovered.
And that brings us to the end of our deep dive into the sun.
Great deep dive.
We hope you enjoyed this journey into the heart of our nearest star.
I did.
Until next time, keep learning, keep exploring, and keep diving deep. Welcome back to our deep dive into the sun. We've learned so much about its structure, its activity, its impact on Earth and the solar system, and even its incredible journey through the Milky Way.
It's been quite a journey.
It really has. And I have to say, one of the things that really stuck with me is this idea of the sun's life cycle.
Yeah.
It's just mind-boggling to think that in billions of years, our sun will transform into a red giant,
Right.
engulfing the inner planets.
Yeah, it's a pretty dramatic end for those planets.
It really is.
But, even in its final stages,
Yeah.
the sun will create something truly spectacular.
Yeah, those planetary nebulas,
Yeah,
the remnants of stars like our sun,
exactly.
they're some of the most beautiful objects in the cosmos.
Absolutely breathtaking.
It's like the sun is going out in a blaze of glory,
Yes.
scattering its enriched material back into space to give birth to new stars and planets.
And that material will contain the building blocks of life.
Wow.
Perhaps even seeding new worlds with the potential for life to emerge.
I love that thought. It's like the sun's legacy will live on,
It
will
will.
scattered across the galaxy.
Throughout the universe.
But before we get too philosophical here, I want to circle back to one of the mysteries that we touched on earlier,
Right.
that corona heating problem.
Yes.
The fact that the sun's corona is millions of degrees hotter than its surface,
Yep.
it's still baffling to me.
It's one of the most enduring puzzles in solar physics.
I can imagine.
There are many theories, but no definitive answer yet.
Yeah.
Some scientists think it might be related to the sun's magnetic field and the way it interacts with the plasma in the corona.
Okay.
Others believe that these tiny explosions called nanoflares
Nano.
happening constantly in the corona
Okay.
could be responsible for heating it up.
So it's like a cosmic detective story.
It is.
Scientists are gathering clues,
Yeah.
analyzing data,
Yeah.
and trying to piece together this puzzle of how the corona gets so hot.
It's a fascinating challenge.
I bet it really is. It's a testament to the fact that even though we've learned so much about the sun,
Right.
there's still so much more to discover.
Yeah. And that's what makes it so exciting to study.
I can imagine.
It's like every new discovery just leads to more questions.
Exactly.
And it makes you realize how much we still don't know about the universe.
It really does. Well, I think we've given our listeners a lot to think about today.
I hope so.
We've journeyed from the sun's core to its outer atmosphere, explored its impact on Earth and the solar system,
Yeah.
and even contemplated its eventual fate.
It's been a comprehensive deep dive.
It really has, and I hope our listeners have gained a new appreciation for this incredible star.
I hope so too. The sun is more than just a source of light and heat.
Yeah.
It's a complex and dynamic object that plays such a crucial role in shaping our world
Right.
and our place in the cosmos.
And as we mentioned earlier, it's full of mysteries.
So many mysteries.
Waiting to be unlocked.
Yeah.
So to our listeners, keep looking up.
Keep asking questions.
Keep asking those questions and keep exploring the wonders of the universe.
Absolutely. There's always something new to learn.
And that's a wrap for this deep dive into the sun.
Thanks for having me.
Thanks for joining us, and until next time, keep diving deep.